Hey everybody, welcome to Bill Sky, the Assembly Guy, and today we're going to take a look at how to actually write your own function or your own syntax, your own algorithm for writing things out to the console, for writing data out to the screen. Now, if you've been following along with my videos, you might have been using the Komanetsky's function library, which is basically you just have to call the function and it writes what you want it to write. Or if you were using the Irvine Libraries from Kip Irvine from his great assembly language book, maybe you were using that. But what are the internals of those functions? How do you actually do those? Now what we're going to do in this video is we're going to do both the 32-bit and the 64-bit, and we're going to do the 32-bit first. We're going to convert it to 64-bit, and then we're going to go ahead and then we're going to do that on Linux, and then we're going to go ahead and do that on Windows. So there will be links, chapter links in this video to jump you to those if you'd like, but I recommend that you look at the entire video because then you can see the difference between Linux and Windows, and Mac is a lot the same. Now this is going to be for Intel only. I'm going to do another video on ARM, but for right now we're going to look at Intel only. So let's get started on Linux, writing things out to the console. Okay. I have a couple of projects set up here. I have a 64-bit console output and I have a 32-bit console output. Now let's do the 32-bit console output and I will show you just how easy it is to convert that over into a 64-bit. So let's do the 32-bit first. Now I wouldn't be willing to say that it's easy to move it from 64 to 32, but because there still are some 32-bit computers out there, it might not be a bad idea to know how to do both 32-bit and 64-bit. So what are we doing here? We're going to just write out a string to the screen. And it's actually pretty simple. On 32-bit, we're going to go ahead and create a string variable. So I'm going to say, I don't know, welcome string. You can call it whatever you want. And I'm just going to say welcome to my program. Now it's very, very important that you do zero delimit. You end your string with a null. And the reason for that is because null is the stop sign for all strings. In any language. That's just the way it works. You zero null terminate your string. This is the same in C and C++. Even the string class has that. It has zero terminated C strings. So you want to put that at the very end always. Now, what if you don't? Well, when do you stop printing? When will the operating system know when to stop printing, starting at the W and welcome to my program? There's no stop sign, so it's going to go on and on and on until you get a segmentation fault. And you can demonstrate that yourself if you want, but you always zero delimit. And that's just the way it is. In all of computer science, it's always done that way. Okay, so now that we've got a string, how do we actually print it? Well, I'm going to come down here and let's just go ahead and put the code in there. So what I'm going to do is first of all, I have to figure out how long is the string. So it would be a good idea on Linux to just say dot length of equals $ minus welcome string. So this is the easy thing, is that if you're going to be creating a constant for the length of your string, this is so easy because you need to know the address of the string and the length of it. Or if you don't want to know the length of it, you can use the zero in a loop to figure out how long it is. But let's do this one first, and then we're going to go ahead and do the second one where we don't specify the length. Okay, so the first thing that you want to do is you want to tell the operating system. What you're going to do is you're going to poke the operating system. You're going to what they call interrupt it. You're going to issue an interrupt. And the interrupt is basically that. Hey, operating system, I am interrupting you, and I want you to do something. I want you to print something onto the screen. I want you to ask for user input. I just want you to do something. I'm going to interrupt you. And a lot of times they'll call that poking the kernel. You can call it that if you want. I think is actually a pretty good way of saying it. Okay, so what you need to do is to actually poke the kernel, we do a thing called interrupt 80. And I'm actually going to say poke the kernel. Now we're not ready to poke the kernel yet, but that is the interrupt. Interrupt 80H on Linux means that I want to interrupt the operating system and I want it to do something. Now, how do I tell the operating system what I want it to do? Well, I have to move into EAX some number. And what we want to do is we want to write that string to the screen. And we're going to talk about what that number is in just a moment. Then we need to move into EBX where we want to write it. We're going to want to write it. Where do we write it? We want to write it to std out, standard out, and that's basically the console. So I've got question marks there because what we're going to do is I'm going to put constants in there. I'm going to actually define those constants because you use them so often. Okay. The next thing you need to do is you need to move into ECX the actual address of the string. Now, why am I putting things into EAX or EBX or ECX? And that is operating system dependent. Okay, on Linux, this is how you do it. On Windows, you'll do it a little bit differently. But on Linux, this is how you do it. It's just like a menu, right? It's a checklist. EAX must get what we want to do. EBX gets where we want to do it. And ECX has what is the source of what it is that we're trying to do. So that's what we put in there. And then we want to do one other thing. We want to move into EDX the length of the string. And then we can call 80H. All right, so that's basically how you tell the operating system to do something, is that you fill up the registers with these values and you go ahead and then you interrupt the operating system. And with 32-bit, we use int 80. Now, 64-bit, we also use an interrupt, but we do a thing called syscall, but we'll talk about that in just a little while. Okay, so now we have to fill up these question marks. What are those values? Well, we want to do a system write. So what I'm going to do is I'm going to say syswrite. I'm going to create some constants. And the reason is because I don't want to have to memorize the number 4, the number 1, the number 2. I just want to have some kind of constants. And I want to go to standard out. So I'm going to say standard out is equal to 1H. Now, where do you find this information out? Well, you find out the values of these in the programmer's guide for your processor/operating system, specifically the operating system. And if we have time in this video, I'll show you where to find those things. But those are the two values. Now, there's other ones you might want to do. There's another one called system read. That's equal to 3H. And instead of standard in, maybe std in, or standard out, std in. Oh, gotta have EQU. And standard in is the keyboard. So those are the 4 constants that you need to be able to do standard keyboard and console input and output. Okay, so with that said, let's go back down here to our code. And we want to write, so instead of the question marks, I'm going to replace that with syswrite. And since we want to send it to standard out, I'm going to say std out. See how much easier that is? And I'm going to go ahead and put a comment right here, write out our welcome screen, or welcome prompt, or string, or whatever it is you want to call it. Okay, so let's go ahead and build this. Oh, I love it when it builds the first time perfectly. And then I'm going to right-click on this. And I'm going to run it. Look at that. Welcome to my program. Totally cool. It worked the first time. I don't think I've ever been happier. Now, there's something else that you might want to do. If you notice in that print, it didn't actually go to the next line. And the bash script prompt printed right after it. So how do you actually get that to print on the next line? Well, what I'm going to do is I'm going to create another variable called endl. And I'm going to say .length of. Now, why am I using endl? It's what they use in C++. So and most C++ programmers know what that is. Or I could have called it new line maybe. Something like that. Let's do that. Let's call that new line. All right, awesome. And so now, how do we print the new line? How do we go to the next line? Well, this is going to get a little bit repetitive. I'm just going to copy the code that I did for my welcome string, and instead of welcome string, I'm going to say new line. Let's save and build that. All right. Now remember what it looked like here. The prompt for the operating system was right at the end of the string. Let's go ahead and run it now, and you can see now that it moved to the next line. But as you're noticing here, this is a little bit cumbersome because every time you want to write something, you have to do all of this work right here. So there's a couple of things that you could do. I'm going to create a function called writeString, and I'm just going to say return. And I'm not going to bother about doing anything, stack frames or anything. Let's just do a quick one. And normally what you'll do is you'll just have those at the beginning, have those sys_write and standard out, set those up. And then what you'll do is in your code, you'll actually do this. And then you'll call this function. So let's actually put that int 80 there. So you're eliminating some of the code to make it a little bit less. Okay, and then I'm just going to say call writeString. And then down here I'm going to say call writeString. So we've eliminated a little bit of code here. We've made it a little bit better. Okay, let's test it. Works great. So now we've got a simple little function. But what if we want to actually write a real function where I don't have to, as the main or the main function, the main programmer, I don't want to have to know if things go into ECX or EDX. Well, what I want to do is I want to push those. So I would do something like this. I would say push welcome string, and I would push welcome string.length of. That's really the way that you want to do that. And I'm going to go ahead and do that same thing here with new line. Now, I'm not sure if I can push a constant like that. Let's go ahead and save it and just make sure. Yeah, it lets me do it in x86. And then I can call my write string. However, my write string is going to get a lot more complicated. And what I mean by that is my write string is going to have to have a stack frame, and it's going to have to grab the variables that I pushed onto the stack. So let's go ahead and do that. So I'm going to go ahead and push EBP. I'm going to push I'm going to move, sorry about that, EBP kind of ESP. Okay, so that's our stack frame. Now, if you don't know about stack frames, take a look at my video on stack frames. And then I'm going to say move, I'm going to get rid of our stack frame. I'm going to pop EBP, and then I'm going to return. Okay, so the EAX and the EBX, the sys_write and the standard out, that will stay the same. But I want to move the variables that I pushed onto the stack, sending them to this function. So now this function is the only one that has to know that ECX is supposed to get the address of the string. So I'm going to move into the address of the string EBP plus 12. And I'm going to move into EDX the length. Now, how did I know to put plus 12 or plus 8? take a look at the stack frame of videos that I did. I explain all that stuff. I draw it out for you, and you should get it. Okay, that looks good. Let's go ahead and build it. All right, it builds. Let's make sure it runs now. It runs perfectly. So now we have a real write string function. We have a function that has a stack frame, just like you would have, you know, the standard for writing functions. It destroys the stack frame. And then this function is the only one that needs to know that EAX, EBX, ECX, and EDX have to be used to write a string to the screen. Okay, now let's take a look at this on 64-bit. So I've got another project up here. And let's go ahead and edit this. This is a 64-bit one. Now what we want to do here is we're basically doing the exact same thing as the 32-bit. The only difference is that we have to use different registers. Okay, so let's take the code that we did on the 32-bit one, and I'm just going to copy it in the 64-bit one. You're going to see how simple this is. So I'm going to take this write string function, and I'm just going to copy it to my 64-bit version. Now on 64-bit, you've got a couple of different things. RAX instead of EAX. You're going to use RDI instead of, what was that? Instead of EBX for where we're going to do it. Instead of ECX, we're going to use RSI. And instead of RDX, or instead of, what was that we were using? Instead of EDX, we're going to use RAX, okay? So again, where do you find that stuff? You find it in the documentation for your operating system, the programmer's guide. And also, we've got a couple of other things we need to do. We're not using EBP, so we're going to change these to RDP and RSP. So get all that stack frame stuff done. And instead of 12 and 8, we're going to use 24 and 16 because 64-bit is twice as big as 32-bit. There's 24 and 16. Now, one thing that we didn't do in the 32-bit version is we didn't release our attribute or our the data that we sent to the function. So I could have said pop. I could have done that. That's kind of clunky, right? Or I could have just said return 16. And what that does is that pops those two things off the stack. Now, what two things? The two arguments that we sent this function. So I can say pop 16. Now, again, go take a look at the stack frame video for more details on that. So because there's two arguments that we're sending here, and each one is 16 bytes instead of, or is it? Yeah, each one is 64 bytes instead of 32 bytes. We want to say return. Is it 100? No, wait a minute. I've got this wrong. I'm thinking of bits, right? So we want to return 16 bytes. And over here, it's not 16. We're going to return 8. So the 32-bit one, we're going to return 8. The 64-bit one, we're going to return 16 bytes. Why? Because every argument is 8 bytes in 64-bit. In 32-bit, every argument is 4 bytes. Okay. Now, I actually want to rebuild this now that I made that change. I want to rebuild it on the 32-bit one, and it still works great. All right. So a couple of the things I want to copy. I want to copy my welcome strings. So I'm copying these from the 32-bit program in the 64-bit program. So those copy right over. I'm also going to copy over my calls. You're actually going to be really amazed at how duplicated all of this is. Okay, so let's put our calls there. All right. Now, there's one last thing that we have to worry about here. Instead of interrupt 80 on 64-bit, we do a thing called syscall. And syscall is a built-in function in the assembler for 64-bit. It does the interrupt for you. You don't have to know the interrupt number, and it's of great use. All right, so I'm going to take a quick look at here and make sure everything looks pretty good. Yep, that looks pretty good. Now, one thing I do want to check is I want to make sure syswrite. Oh, we didn't do that, did we? Right? We didn't put the constants in the 64-bit. So I'm going to go ahead and copy those. That's the one thing we didn't forget, or we did forget. I'm going to copy those here. And I do not believe those are the same in 64-bit as they are in 32-bit. So let's take a look at what those would be. I'm looking in one of my notes here. And let's take a look. So on 64-bit, syswrite is not 4H, it's 3CH. Sysread in 64-bit is not 3H, it's 0H. Syswrite, I'm sorry, syswrite is 01H. Oops, got that wrong. Okay. And sysread is 00. Standard in is 00, so that's the same. Standard out is 01. So those are the same. So our syswrite and our sysread are a little bit different. Now the really cool thing about using these constants is I only have to change them up here. I don't have to change them down in all my code because I use constants. Let's go ahead and build this 64-bit version. All right, great. Let's go up here and let's test it. Segmentation fault. Oh my God, what did I do? Well, let's take a look at what I did. We obviously have a problem. So it might be a good idea to debug this, but let's take a look and see if there's anything really outstandingly. Nope, so we've got that. Length of welcome string, everything there looks good. So it must be something within here. Let's debug this and see if we can't figure it out. And the way I'm going to do this, I'm going to go ahead and just put a breakpoint right here. Let's make sure we didn't... Oh, there it is right there. EBP. Isn't that interesting? I go to debug it and I see the problem, but in the source code I don't. So I'm supposed to be using RBP instead of EBP. Something I didn't change when I copied it over from 32-bit to 64. Let's go ahead and try it now. And it works great. So we didn't even have to debug it. Now, there's always a question at this point from my students is, all you're doing is printing a string. How do you print a number? Well, I'm going to do a completely different video on printing numbers to the screen. It is not a small effort. And the reason is because numbers are not something that you can show the user. ASCII values are. So wait for that video. It's coming up soon. What you have to do is you have to take that number and you have to divide it by digit, and then you have to add hexadecimal 30 to that number so it matches the ASCII tables. So we'll take a look at that at the next video. All right, so let's take a look at how we do this on Windows. Now, if you skipped ahead and you didn't watch the Linux version, I really recommend you go back and watch that Linux version so you can see how different operating systems do things differently. But we're going to do everything from scratch here. All right, so get rid of the little irritating Windows things. All right, so let's take a look at our code. Now, I have two projects here. I have the 32-bit one, and then I have a 64-bit version. Now, we're going to do 32-bit first because you're going to see how easy it is to copy that code over to 64-bit. Just make changes, and now you've got both 32-bit and 64-bit. It's not so easy going the other way. Well, maybe it is, but so let's go ahead and take a look at the 32-bit version. So the first thing that we need to do is we need to create a string that we want to print. So I'm going to say welcome prompt by byte, welcome to my program. Now, one thing you always want to do is you want to make sure that you null terminate all of your strings. You really must do that. If you don't do that, where's the stop sign? 0h null is basically a stop sign for terminated, for the end of a string. And this is done in just about every language I can think of. It's kind of like the one standard across all languages, is that you terminate it with a 0. If you don't, it's going to go on forever or until it gets a segmentation fault. And we've all seen those, so always 0 terminate your strings. Okay, so what we want to do here is that we want to actually call a function which is part of the Windows library. And we're going to do that with an invoke. So, but there's a whole bunch of stuff that you have to provide to this function. And the name of the function is write console A. And you need to send a bunch of stuff to it. You need to send what they call the screen handle. We're going to talk about each one of these. You just send the string address. That is the address of your actual string. You want to send the string length. And then you want to send the address of an output counter. We'll see that in a second. And then 0. We're going to talk about each one of these. Now, before you actually do that, you have to fill those values in, okay? So what we're going to do is I'm going to move into EDX. Now, we don't have the length of our string here, but I'm going to move into EDX. Length of welcome prompt. And I didn't type that, or I didn't type that up correctly up here. Okay. Now I'm going to comment this out first, that invoke, and we'll get back to it because I just want to build these and make sure I haven't made a mistake. Okay. Oh, it looks like I have to retarget this, so bear with me as I retarget the solution. And let's go ahead and build it again. Problem should go away. There we go. Okay. So everything looks good. So we've got our welcome prompt. So we're going to move into EDX, the length of the welcome prompt. Now here's the thing, is that in Windows you can't use registers to send the data to the function. You have to use variables. So what we're going to do is up here, I'm going to create a variable called string length. And I'm going to say define double, and I'm just going to give it a 0. So I'm going to say move into string length EDX. So there's the length of our string. Now what else do I need to do? I need to get what they call a standard handle. I have to get, in Windows there's these things called handles where they're like pointers, and I need to get the pointer to the standard output. So to do that, I have to invoke a function called getStandardHandle, and I have to tell it that I want to get the output handle. And that actually goes into EAX. So once I do that, I'm going to say move, and I have to put in a variable, screen handle. And I haven't created this variable yet. We're just going to do the code first. EAX. Okay. So, whoops. So let's say screen handle, define double, 0h. I could have put a question mark there on Windows as well. Okay. Now, I don't think we have output handle defined yet. Yeah, there's a number of constants we might want to create before we do anything here. I'm going to go ahead and put those constants up here. So output handle is equal to -11. Don't ask me why, but that's what it is, decimal. Let's put a couple of more that you might want to put. Input handle, that's equal to -10. Then we've got the syswrite. Now why am I creating these constants? It's so I don't have to remember these strange numbers. Syswrite is 4h and standard out is 1h. That's one thing that's nice. It's common with Linux. So instead of having to know these numbers, instead of having to put the number 11, the -11 there, we can just say output handle. Okay? So let's go ahead and build this. Make sure I didn't type in anything wrong. Oh, get standard handle. Oh, okay. So there's a number of functions that we have to prototype. And let me go ahead and just copy and paste those. So it doesn't know what get standard handle is. So we have to prototype them up here, just like we had to prototype the exit process. So get standard handle, it just looks like this. It takes a double word, which is basically the one argument it takes. Write console A, that's the prototype for that function. It takes all these different arguments to it, and we'll talk about those later on. And there's also read console A. When I do the video on reading data from the keyboard, I'll show you how to do that. But I've got that there just because it was available. So let me go ahead and build this now. All right, cool. So I'm not quite done yet. Now, if you watch the Linux version, we would have been done by now, right? But Windows is a little bit more involved. All right, so this one here, this is the length of our string. And this one is the where will we write it to. Okay. Now, we're not quite done yet. Not by a long shot. Let's go ahead and now we've got a whole bunch of these arguments. That's basically what we're doing is we're filling in the arguments. So we finished screen handle. Screen handle is done. We finished string length, but now we have to do string address. The output counter, we'll take a look what that is, and we call the write console A. So let's go ahead and now let's do the address of our string. So the address of our string, we're going to move into EDI, the offset, and I like doing those macros. And what was the address of our string? Offset of welcome prompt. And then I'm gonna move into a variable string ADR EDI. And I haven't created that yet, so let's go ahead and do that up there. Again, I could have put a question mark, but I'm going to put 0h. All right, let's build that. All right, we're slowly getting there. Actually, I think we're done at this point. Now, I don't think I have output counter. So let's uncomment the invoke. And yeah, it doesn't understand what output counter is. So let's go ahead and take a look at what output counter is. Now, what output counter is a variable that will just contain the total number of characters output to the screen. So I'm going to say output counter. Find double question mark. All right, let's go ahead and build that. Okay. Now, one thing that we didn't do was this very last one. We just sent a 0. Let's take a look at the prototype for write console A. And that is a reserved double word. So you don't do anything in there. I'm not sure what that is. Maybe Microsoft might want to use that in future versions of their assembler. But for right now, we just send it 0. Let's rebuild it, make sure everything's good. Okay, let's debug it, start without debugging, and see if we get our print. And we certainly do. We get our print. So that's how you do it on Windows. Now, you would do the same thing with an end of line. So you might do something like this, end L, defined by 0AH, 0DH, and 0H. So an end line is basically just take me to the next line, to the beginning of the next line. So you kind of have to do all of this again. So let's go ahead and copy. I know this gets a little bit. Okay. So I'm going to say end L. There's the string length. We get the output handle, screen handle. That's it right there. Okay, then we have to get the address of that. So we're going to say end L. And now let's debug it without debugging. And now we get a blank line. There's that blank line right there. So you're noticing in this that there's an awful lot of duplicated code here. A lot of this is the same. So what I'm going to do is I'm going to create a little function. So I'm going to create a function called print or write string. So let's go ahead and just do that. Let's just create a function that does some of that. So I'm going to say write string np. Okay. Now if you're going to use this, now we could do this very easily where you just fill the stuff in and then you call the function. But let's do this with a stack frame. If you want to see an easier way, but isn't the standard, it's really not the way you should write functions. Take a look at the Linux version. But let's just jump right into a real function here. Now, I'm going to create a stack frame. Now, if you're not sure about this, take a look at the video that I did creating stack frames. So let's create our stack frame. All right, and now let's put in the code to get rid of our stack frame. All right, great. And then we're going to go ahead and say return. All right. So let's take a look at some of the things that are pretty standard. Well, we've got the get handle function. So that's the same in both of those. So let's go ahead and put the get handle in there. What else? We also have the invoke. So let's put the invoke in there. Okay. So we can get rid of those out of these two. So what's left? Well, the only thing that's left is the length of the welcome prompt or the length of the string and then the actual address of the string. So what we would do there is I would say push length of welcome prompt. Let's actually build this and make sure that that works. Yep. So instead of doing this, I would say push welcome prompt. And instead of the length of, I'm going to say, actually, let's do this. Let's push the address of the welcome prompt first, and then let's push the length of the welcome prompt. Now, why am I doing it that way? Because it's the same as I did it in Linux. So then we're going to call write string. Now, there's a couple of things that we have to do here, but let's go ahead and now do that for end L. Push the offset end L, push length of end L, and then call write string. All right, great. Let's go ahead and build that. Now we deleted a couple of things out. Oh, yeah, I think I have to have these inside of the end main. So let's go ahead and do that because it's telling me that it doesn't know where they are. So let's put that in here. For those of you that watch the Linux version of this first, it's amazing how easy it is compared to this. This is really kind of a pain in the neck. Okay, so now how are we going to actually do this? We put the two arguments. We put the address of the string and the length of the string onto the stack. In our write string function, we have the stack frame, but now we have to grab that data out of the stack. So the way we're going to do that is I'm going to move, and we have the variable up there, so I'm going to move into EDX EBP plus 8. EBP plus 8 is the size of the string. And then we have to move that into string length. Now, if you don't understand what this EBP plus 8 is, take a look at my stack frame video. It tells you all about that. Okay, so I still have to do the invoke, so there's the invoke. So now what I'm going to do is I'm going to move into EDI the second argument, or I should say the first argument, the address of our string, and then I move in the string address EDI. Now another way to do this, I'm using global variables here, string address and string length. Instead of using global variables, what you could do is you could allocate a variable inside of your function by subtracting, in this case it would be subtracting 8 from ESP and put the data in there. But I'm just using global variables just for simplicity's sake. Okay, so this looks a lot like what we had before we had our function. So let's go ahead and build this. And now let's debug it, start without debugging, and it's working. So now instead of having to know all of this stuff every time you want to write a string to the screen, you just need to know these 3 lines of code. You push the welcome prompt address onto the stack, then you push the length of. Now if you're a little bit confused about this EBP plus 8 and plus 16 stuff, go take a look at the stack frame videos that I have. I'll put links to those in this video, but that's how you would do it on Windows 32-bit. Now how are we going to do this on Windows 64-bit? Well, Visual Studio is a little bit of a pain in the neck. You can't really copy things over like you can. So I'm going to open up my Notepad app. I love this Notepad++. And I'm going to go ahead and just copy my code into my Notepad++. So I can have it there. And now I'm going to go up to File, Recent Projects and Solutions. Here's my 64-bit version. So I can do a lot of copy and pasting here. So that's my 64-bit version. So let's take a look at this. So let's go ahead and do these prototypes. And I think we're going to have to make a couple of changes there, but that's okay for now. Let's go ahead and put these constants out here. And I believe a couple of those have changed as well. Let's go ahead and take our write string function. And let's put that in there. And we can do almost all of this. I don't like to do it all, but we can do almost all of it. Let's put our welcome prompt. There's our welcome prompt. And then let's do our calls. Okay. So pretty good. Now if I build this, we're gonna get a number of errors. Oh, it's gonna make me update my retarget it. I just love that about Visual Studio. But we're gonna get a bunch of errors here because the prototypes are different. So let's take a look at what those would be. So let's take a look at the first one. So it's telling me here you don't put a comma. In 64-bit, you don't put a comma after the proto statement. So I'm going to get rid of all those. 32-bit, you do need that comma. Okay, let's take a look at this one. All right, so the exit process, you don't specify. And unfortunately, I have this already up here. So in the exit process for 64-bit, I accidentally copied that. I didn't really need it. So that was my first error. So let's rebuild it. Okay, good. So now we have to do a few more things here. Now we're away from the preprocessor, and it looks like we can't push in 64-bit. You can't push the offset involved. So what I'm going to do is I'm going to move into RDI the offset of welcome prompt, and I'm going to push RDI. So you have to move it into a register before you push it. Okay, let's see what this one is. All right, same thing here. So I'm going to move into RDI the offset of endl and then push RDI. Okay, let's see what else we've got here. Okay, so it looks like our main proc is ready to go. Now we have to go into our write string proc and change all the E registers to R registers. So let's just do that. And we have a few more changes to make here. Okay. Again, the invoke, to get standard handle, you don't say invoke in 64-bit, you have to say call. And we're not going to say anything with the get output handle. It doesn't require it in 64-bit. They made enough of a change there. And before you call that, you have to move into RDX, or RCX, sorry about that. So this is how you get you have to put the output handle value into RCX and then you call get standard handle. It doesn't take arguments like it did in 32-bit. Okay, great. Okay, we got another problem down here on the invoke. Now we're not going to invoke write console, we're going to call it. And it doesn't take all these arguments. So you just take those off there. So what do we have to do here? Okay, so I need to create screen handle. I have to, and there it is right there. So let's split these things up. Okay, so what I'm going to do is I'm going to get the size of the string, and that is going to be in RBP plus 16 because 64-bit is twice the size of 32-bit. So we're going to move, say RBP plus 16 string length. Now we want to get the output handle. It looks like that looks good. We've got that. That looks correct. That's now an RAX. And then I need to get the address. Okay, so I need to double this. I'm going to say 24. So that's the address. I'm going to move RADI. There we go. Okay, so it's looking good. All right. So this is exactly the same as it was in the 32-bit version, except we just changed all of the E registers to R registers and so forth. Okay, so now that we've got that data, now we have to fill up the registers with this data. 64-bit call works completely differently. So I'm going to move into RCX, the screen handle. I'm going to move into RDX, the string address. I'm going to move into R8, the string length. And I'm going to move into R9, the offset of output counter. Remember, output counter will say how many things are actually put into this, output to the screen. So let's go ahead and see. Okay, we still have some problems. I didn't change all the E registers to R registers. And we don't have these variables set up. So we also have to set up those variables. So there's string lengths. So let's go ahead and copy those. Now those should be 64-bit. So instead of doubles, we're going to make those quads. And I also believe that these are going to be a little bit different too. Get standard handle, write console. So they're not going to be quite the same as 32-bit, so I'm just going to copy and paste them here. And again, where did I get all this information? I got it from the Windows Programmer's Guide on how you execute those statements. Let's rebuild it, see what we got. All right, it worked. Well, it didn't work, it assembled. Why did it assemble? Because I put those values there. Now, let's look back at this code a little bit. Why did I do all of this stuff? Why didn't I just move them directly into the registers? Well, I could have, okay? The way that I wrote this code in my functions library, I took the 32-bit version, copy and pasted it to the 64-bit, and made changes. So it is very, 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 very possible that I could have just gone ahead and not done all of this. But because I just converted it, I never went through and really optimized it, got rid of the lines of code I didn't need. Like for instance, the string length here is going to RDX when I could have just put it into R8. So I could have done this, R8, and then I could have gotten rid of that line of code. The output handle, I still need to do that for the output handle. However, for the string address, I could, instead of doing to RDI, I could have just done to RDX and got rid of that. And then I wouldn't have needed this line of code, this one right here, and I wouldn't have needed, I believe, this line of code. So these two lines of code could have been gotten rid of. But I'm just going to leave it the way I had it because I know that works. And let's build it. And then let's run it. And the program worked great. So what did we do here? We took all of this code, we created a function called writeString, and whew, Windows is a little bit more involved than Linux. If you didn't watch the Linux one, go back and watch it. You'll get a much better appreciation for how Linux does it. The 64-bit version of Windows is more like Linux. A lot of that code I cannibalized from my 32-bit. Phew! Just writing things to the console, not as easy as you thought. Took a lot of time to do this video. The next video we're going to do is for data input, keyboard input. How do we get input from the user using the registers, poking the kernel. And then after that, I'm going to do a video on numeric printing, actual printing numbers to the screen. Hope to see you at our next video.